When you think of AI, you probably think of humanoid robots from science fiction. But I'd guess that today many of you have spoken with Alexa or Google Assistant or Siri, and you'd pretty much immediately recognize that as being AI. But you also might have been diagnosed or prescribed medication today because of AI. You might have had no trouble buying toilet paper at the grocery store because of AI. You might have avoided the traffic today because of AI. The AI that affects our lives is often not visible to us. You're depending on it and you don't even know it. I'm Dan Huttenlocher, and I'm the inaugural dean of the MIT Schwarzman College of Computing. When we talk about AI today, we're also talking about machine learning. Think about it this way. AI refers to the intelligent-seeming behavior of a system, while machine learning is a technology that enables AI. AI work has been going on since the 1950s, but the last decade has seen huge advancements. That's because of powerful new machine learning methods, and also because of large increases in the amount of data available for training machine learning. When people are equipped with knowledge about computing and AI, in addition to their field of expertise, they can go out and make things happen at an unprecedented rate. People who are educated this way are what President Reif calls computing bilinguals. They're the type of students we're here to educate at the Schwarzman College of Computing, and the type of researchers whose work we're here to advance. To be bilingual in this way, you need to know the language of computing and AI as well as the language of the domain you're using it in. MIT is the natural place to be at the forefront of this transformation. AI in health and in scientific discovery are active areas for us. That includes individual projects and bigger organizational parts of the college, such as the Jameel Clinic, where the entire mission is focused on machine learning in health and on tying fundamental research to clinical outcomes. While the COVID-19 pandemic has belatedly focused necessary attention on the huge societal consequences of novel viral infections, other looming public health crises similarly pose urgent needs for new treatments. A particularly concerning one is bacterial infections. Today's antibiotics are becoming less and less effective because bacteria are evolving to become more resistant to them. This evolution is happening at a frightening rate, rendering not only existing, but even new antibiotics ineffective because of their similarity to existing ones. The challenge has been the difficulty of finding new antibiotics that are significantly different from the ones we have, and thus are effective against drug-resistant bacteria. In the Jameel Clinic, professors Jim Collins and Regina Barzilay have been able to identify an antibiotic candidate that's extremely effective against drug-resistant bacteria in the lab, as was announced about a year ago. Machine learning plays a critical role in this important discovery, and perhaps even more importantly, holds great promise for other discoveries. To find new antibiotics, there are so many possibilities that it's not practical to try even a small fraction of them. So one must somehow identify promising candidates. This is where machine learning comes in. Jim and Regina developed new machine learning methods to radically improve this discovery process. The particular antibiotic candidate they've identified has been proven in the lab, and that still leaves a large amount to do before it could be shown to be something safe and effective in people. But even at this stage, it's a major advancement, a surprise even, because of how hard it has been to identify potential antibiotics that are effective against drug-resistant bacteria. As important as it is to have effective antibiotics, AI is increasingly used in discovering other important and surprising things. And I find that the word surprise is very useful here. We're beginning to see what amounts to AI and human collaboration in scientific discovery. We've thought of AI as another computing tool, but to me, a tool doesn't really surprise you when you're using it. A collaborator surprises you. Positive surprise is something like the discovery of a new antibiotic candidate, but surprise can be negative as well. And understanding and refining possible negative outcomes of machine learning is an important goal of the college. The function of AI depends on data you train it on, which in some ways isn't all that different from humans, whose behavior can depend a lot on what they are taught. We all can agree as a society that we've got to do better at training and testing AI more broadly and deeply, no matter what its function, to help prevent outcomes such as bias or discrimination. These problems are not unique to AI. Pulse oximeters, those little things that go on the end of your finger to monitor your blood oxygen levels, are an example of a tool developed decades ago with a potentially fatal such problem. It turns out that their accuracy is lower for darker-skinned people than lighter-skinned ones. But if we are coming to rely on AI as more than a tool, then it is also all the more important that it does not succumb to such problems. We need AI to be well taught. So to me, the really exciting broader question about AI and machine learning is this: in what ways is it more than a tool? How can you say it's a tool when it's leading to such life-changing discoveries in areas that have already been heavily studied by people? These are areas that experts have been looking at using powerful tools for a long time. And yet AI and machine learning are producing surprising results. And that's why it's so hard to begin to understand or even to name the relationship between people and AI. The fact that we're wrestling with what you should even call something is compelling. It's impossible to think of Siri or Alexa as a collaborator, at least today. It's even hard to think of that interaction as a conversation. So is it that scientific discovery is an exception? Or is AI soon going to surprise us with results in many areas, like a smart colleague might? So you can see all of this is new, puzzling, and changing quickly. And speed matters, not just so we stay at the forefront of AI and machine learning fundamentals, but AI applications are developing fast, and we need them to, especially in terms of healthcare. And back to this notion of computing bilinguals. It's not just about helping AI and computer science experts understand the new world. You have to help people in other areas understand it too. To get the most positive benefit and minimize possible negative outcomes, we need collective understanding. If you're an expert in computer science, for example, you probably aren't an expert in economics or philosophy or marketing, so you don't understand those kinds of outcomes. And vice versa for the economist, philosopher, or marketer. And it's for this exact reason we're educating computing bilinguals. We're helping students and researchers combine computer science and other disciplines in addressing the world's hardest problems, those that people have not been able to solve alone, and at the same time, attending to possible unanticipated consequences of such solutions. It's in MIT's DNA to lead in thinking and doing. Truly integrating computing across MIT, that's how we'll take unparalleled leaps in making a better world.